Okay, as you see, I have a problem on the board. I'll step out of the way so we can read it. Here, the problem is in black, and we're going to put our solution here in blue. Okay, we believe a new treatment is more effective than the standard treatment for prolonging the lives of terminal cancer patients. The standard treatment has been in use for a long time, and from records in medical journals, the distribution is known to be approximately normal. That's something we need to know. With a mean survival period of 4.2 years and a standard deviation of 1.1 years. The new treatment is administered to 80 patients and their duration of survival recorded. The sample mean was found to be 4.5, tested alpha is 0.05. Okay, so I underline all the numbers that we got to concern ourselves with. Now let's look at here. What we've got here is a null and alternate hypothesis. So the null, you have to use that symbol mu. You're going to have mu and then something else and then a number. That's what's going to be there. You always need mu. Some students decide to leave that off and then just put a number here. That doesn't have any meaning. You just have to put a number sitting there. Okay, so what is believed here? What is the established claim? Well, it's established that there's a 4.2 year survival for cancer patients with that. Okay, here it is. Has been in use for a long time. The survival rate has been 4.2 for a long time. So that's what's believed to be true. 4.2. So that's believed to be true. So we got to check what the alternate is. What are we trying to show? The new treatment is administered to 80 patients and their duration for survival period recorded. The sample mean is found to be 4.5. Okay, we believe a new treatment is more effective. That's what I'm looking for right there. We believe a new treatment is more effective. What are we trying to show? What are we trying to show? It's established 4.2. We want better than 4.2. We think the mean is actually better than 4.2. Now, something I do, our textbook does it, a lot of books don't, is they'll put equals with the null hypothesis always. Now, I want to show the whole number line. So once I establish which direction this one is, I can show that covers the entire number line. Now, when you read this problem, when they say the mean is 4.2, you wouldn't think 4.2 or less, and you wouldn't want to advertise less either. You can die in quicker than 4.2 years. You don't advertise that. So sometimes the alternate is going to tell you the direction that needs to be pointed. Sometimes it will be the null hypothesis. But in either case, this is an established claim, and this is a new claim, a challenge to the established claim. Now, what I'm going to do is after this problem, I am going to go through and do some problems just dealing with the null hypothesis, step one. Okay. Now, let's look at step two. What type of test are we doing? What type of test are we doing? Well, if you remember, I put up, when we did the confidence intervals, I put up a flow chart very much like that. So the flow chart tells you whether you need to do a z-test or a t-test. Is n bigger than 30? Yes, n is bigger than 30. N is the sample size. We have 80 patients. It's bigger than 30. So it says yes, and it says use z. It says right there, use z. So that's what I'm going to do. This is going to be a z-test. Now, how many tails does it have? We're only concerned, and I'm running out of space here. I will put this right here. We're only concerned with the upper tail. The alternate hypothesis will tell you how to draw your normal curve. Draw a normal curve, and we're looking at the upper tail. So this is one tail. Now, what do we have here? Our level of significance. This is a one-tailed test, so we use all of our alpha. Alpha is 0.05. Degrees of freedom. If you remember, I had it written out here. When we're doing a z-test, what are the degrees of freedom? They're infinity. Now, this is going to look very different than what I showed earlier. This is our rejection reason. We're going to reject the null hypothesis. That's what the letter R stands for. When our test statistic is greater than, we'll use these two numbers to look up this value. So if you get the t-table out, and I've got alpha's 0.05 across the top. 0.05 across the top. Then I go down my degrees of freedom here until I find infinity. And that intersection is 1.645. Right there, 1.645 where my thumb is. So this is 1.645. I can then write that number here. That's my cutoff. Think of it, here's my confidence interval, and my data lands in here, then our sample is significantly different than this 4.2 model that they've been using, and we found something better. If we're not significantly different, then we can't say that the 4.2 number is wrong. Even though our 4.5 is a little better, we don't have enough evidence to say that that's true. Okay, now one other thing. When you have a one-tailed test, these two symbols will point the same direction. When you have a two-tailed test, it looks different. Okay, and I'll show you how that looks when we do a two-tailed test. Now, I've got to compute the test statistic. Z equals 4.2 is what was believed to be true. The standard deviation, 1.1. Square root of n is square root of 80. And what was our sample value? Our sample was 4.5. And I'm out of room. Okay, I need a calculator to figure this out. I get a calculator here. I'll step out of the way. 4.5 minus 4.2 divided by 1.1 times square root of 80. Okay, I got approximately 2.44. That equals 2.44. Hopefully y'all typed in and got the same number. Now, couple things we can do here. 2.44, where does it lie? It lands in the rejection regions. So we're going to reject the null hypothesis. Because we rejected the null hypothesis, that meant there was evidence to accept the alternate. Now, that's the way I like to do it, is you can just find out where this test statistic lies on this diagram here, and then determine 4 and 5. If you wanted to, you could go back here and say we're going to reject the null hypothesis if this number is bigger than this number, and it is bigger. So that is stating what this picture is showing. Okay, now that is one example of a hypothesis test. Now, I'll show you, the next video will show you about step 1 a little bit more in depth.